Hello everyone and welcome to our short presentation on the project which we have made for our subject, that is NLP with LLM. The topic of our presentation, rather the project, is text augmentation for enhancing the text classification for low resource language. So there were many fields suggested towards going forward this project, but we chose as text augmentation as we thought that it is one of the very challenging domain as far as the low resource languages are concerned. Now, why it is so, that I will explain further. Now, in low resource language, we are particularly plugged with less amount of data sets. So, if the data set is it's not very huge, it becomes difficult to introduce it to tasks like classification and sentiment analysis. So, once identified the problem, we went ahead with our literature survey, which involved studying various techniques and on doing that we came to know there's something called easy data augmentation, which is primarily a combination of four different techniques as will be explained during the later part of the presentation. uh, and apart from this easy data augmentation, there are many other such techniques which we have studied recently with the development of large language models like GPTs. There also the people have started using them for these data augmentation, but the benefits which observed as far as low resource languages are concerned are very varied in nature, depending upon the amount of data on which these large language models have been trained upon. So just because the large language models have come in, the uh, benefits, or rather the usability of these methods, cannot be easily uh, go away. So we thought, why not to explore these methods and see how it performs in the low resource language setting. So basically, with this as a backdrop, this was our motivation to use such methods, EDA-like methods, and to adopt some kind of variation in it and see how it goes, how it performs on a low-resource language setting. Now, what was the major problem or the major lacuna which we observed in this particular approach was this EDA-like methods were mostly relying upon the dictionary-based things where which they needed it for synonym replacement and random insertion and those stuff. So we just wanted to improve upon it further, where they will be using word to wake model and those kind of stuffs. So this was the motivation for us. So this having got the motivation and decided upon the project, there were many challenges. In fact, first was it how easy or how difficult it is going to be for us to apply easy data augmentation technique, because once we have thought that we are going to use a word to vec like models, it was not readily available. So because of this reason, specific this reason only, we decided to choose Swedish as a language, because its word to vec model was available, and rather than going for the language straight away for which it is not available, we thought, why not to use it for a language for which it is available, and we can build upon it further even if we want to work on this project in the future as well. So this was one of the reason, and we incorporated, rather the one of the contribution which we had from this project is we incorporated the use of word to vec model into while applying the EDA like data augmentation process on such languages. So now Tarun will take over and he will define the problem statement and how we have applied EDA on this Swedish language.
Thank you very much, sir. So, moving forward, let's talk about what is the goal and what is the problem statement and what we want to achieve in the last of this project. So, we wanted to implement a model which generate a synthetic text, or you can say that augment the data for multiple purpose or multiple downstreaming tasks. For example, it can be a text classification task, sentiment analysis, and all those stuffs. And we wanted to see that if these data augmentation techniques are helping us or not to achieve a good accuracy, because without that data augmentation and because of data scarcity, these downstreaming tasks doesn't perform that well. So we tried to use these data augmentation tasks and do this downstreaming task and see if there is a change in accuracy and performance metrics or not. Please move further. So these are our objective. So to make a model more efficient after the data augmentation on the large data set, I will be explaining what is this the large data set in the further slides. Our next objective is to generate augmented data, which I have explained previously. in a such a way that the solution of NLP tasks will perform more accurately, that we can achieve our result in a good way, or we can enhance our evaluation matrix results. So these are our two main goals which we want to achieve in future. So this is the data set that we have using, which is called a Dalal data set. So this is a Swedish linguistic acceptability data set, which is divided into training, validation, and testing set. So it includes total 7,682 training samples, in which half of them are like grammatically correct sentence, and half of them are not acceptable. And on this dataset only, we have tried to build our model, and then use this model to data augmentation on downstreaming NLP task. Uh, Okay, so let me first explain the EDA methodology on which our model is working. One of the main methodology. So this is a like data augmentation technique, which comes in open source, I think in 2019 only. So it like works on four major tasks, which are called random synonym replacement, random insertion, random swap, and random deletion. I will be explaining all of the four in little detail. First of all, what is random synonym replacement? So it is a minute user defined it takes a minute user defined fraction of word from the sentence, and excluding the stop word, and and is randomly selected subsequently, like, okay, and after that each replacement candidate undergoes a substitution with a randomly chosen synonyms. Then what is the random insertion? It takes a fraction of position within the sentence, which is also randomly chosen, and at this selected position a random synonym is inserted into a randomly chosen word in the sentence. uh, what is random swap? A modest user defined fraction of word is randomly chosen and their position are interchanged. While in the random deletion, a slight user defined fraction of word is randomly deleted from the sentence. So these are the four method which we use in like EDA. Please move further. So what is this EDA methodology? So we have input text. So we have the in starting we have the input text of a low resource language, and we use word to vec of that language to use these four techniques. For example, for random synonym replacement, we first select that word from that text and wanted a semantically similar, yeah, or contextually similar word which is available in that dictionary. So initially, as Vaibhav sir explained, that we are not using dictionary, rather than we are going for a word to vec, because word to vec model give a semantically, or you can say a contextually similar word, rather than going or searching for exact synonym. So we are using word to vec model to find a semantically or contextually similar word which will replace that selected input word. This is how it works. First it do all these things: random synonym replacement, random insertion, or random deletion and all. And for these, it use word to vec model to select that words, and then generate an output text. So this is the simple methodology. For the POSSR algorithm, what is the POSSR algorithm and how it works? I would like to invite Anjali to explain.
POSSR algorithm, which is an abbreviation of part of speech specific similar word replacement. So, first of all, let us understand why do we need this algorithm. So, suppose that we are in a situation when we are trying to deal with context sensitive data, especially sentiments. Now, here, the indiscriminate replacement of words with synonym as employed in the random synonym replacement can potentially disturb the underlying semantic meaning of the sentence. So, to resolve this issue, what we do here is, rather than doing the normal synonym replacement, what we do here, suppose that we have chosen a word, then we replace with this word with the synonym which is having the same part of speech tag, so that our semantic meaning of the word is still preserved. So what is the USSR algorithm? We take the original text, we take the word type, and we take what is the sentence count. Now then we iterate till sentence count. Then we select a random word from that text, from our original text, and then we replace with the potential replacement by checking that the synonym to which we are trying to replace it with having the same part of speech tag or not. Now this is the whole algorithm. Now what is the let us discuss its model architecture. It's also simple, that we take the input text, we take the POS token, we find the POS token, and then we try to replace it with the synonym which is having the same part of speech tag, and we get the output text. Apart from this, we have also performed noun replacement algorithm. So what we do here is we just replace a noun with some another noun. So what is its algorithm is we take the original text, we take the word type, and then we take a sentence count. Now we iterate through until sentence count, select the noun from the original text and replace it with its potential replacement. Now we get the text. So let us discuss the results we have on the methods we have performed so far. So we can see here that initially with noun replacement, EDA and POSSR, in all these three algorithms, we can see that initially we are getting good results. We are getting better accuracy, although the accuracy is not very good, the increment of the accuracy not very good, but the model is performing better when after applying the noun replacement, EDA and POSSR algorithm. So here we suppose in the 50%, suppose that we have replaced with the 50% of the replacement. After the 50% of the replacement, we have received from in noun replacement from 0.56 to 0.61761, here in 0.58 to 0.63 and 0.57 to 0.63. So this is the best output we have get when we have replaced with 50% replace after the 50% replacement. Now, as you can see, when we have increased the replacement amount, then our model is not performing very good. The accuracy is now decreasing somewhere, and even if it is increasing, then it is not in very good. The increment is not very good. Now, I would like to hand it over the next result to Major Sir.
So having seen the table, though seeing those different figures at a time becomes very difficult. So we thought, why not let's visualize it with the help of a graph. So if you look at the graph carefully, so these three techniques are represented by three different colors. That is noun token replacement by blue, EDA by some orange, and random synonym by green. So as you can see, all these methods performed somewhat at a very similar level when they are below the 50% marks. And if you see specifically the 40% mark, the EDA outperforms everyone. So it is like if you are using applying EDA, suppose you have got a data set of say 1,000 samples, and you want a data set of 1,000 samples, but only available to you is say 4,000 400 samples. So this is the time when you can go for the EDA method, which will perform somewhat better than the others. But if you have got if you already have a very large data set and if you want to do augmentation on it, so all the methods are performing similar. Though now specific token replacement method like noun token replacement method may not be giving you that benefit. As you can see the 100% marks, the noun token replacement, actually the accuracy is going down. So it is the EDA and the synonym part of speech specific synonym replacement that is actually performing good for you. So before we discuss further, moving with the conclusion and the future work, let's go ahead and see how this methods which we have discussed so far has been implemented in the form of the codes. So here I'll briefly explain how these methods have been how we have implemented this method. So this is This is so basically we have made 3 to 4 mm, Jupyter files implementing different methods one by one in each of them. So this is at the outset. I'll show you how the EDA has been implemented. Uh, we have implemented the basic libraries of scikit-learns and pandas. So this is the particular file where our data set is lying. We have converted it into a data frame. Now, if you look at this data set, primarily uh, this is how it looks like. It has various attributes. So if you look at it specifically, you will find whether the sentence is a corrected sentence, whether it has got any error or not, on those stuff. So this we have read this data set very carefully, and after that we went ahead with making our data frame. So data frame is made in base of the whether the sentences are actually the corrected sentence or they are not corrected sentence, because we are dealing with a classification task. So it is based on the data set how it has been classified. We have made our training and test data sets. So after making the training and test part of it, we are ready to implement the EDA. So for implementing the EDA, our basic requirement, as we have already decided at the outset that we'll be using word to vec model. So we have already downloaded the word to vec model, in which we have kept it in our directory. We have given a path to it, and there is a class called data augmentation class. We have given a path of this word to vec file in that to that particular class, and it has been initialized. Moving ahead, so what we are using over here for this encoding, for the encoding of this our database which we are using uh, bird based Swedish case as our encoder model. Since we were lucky enough that we could find that the bird has already made a model on the Swedish language, so we decided to why not to use it. It has been incorporated. So we have used transformers library, which is built on top of the Hugging Face, and the multi-layer encoder library to basically encode our data set which we are using. So after having decided upon this, all this stuff, we have moved ahead and made few functions. Made I'll specifically talk about the two functions. The first function called frac, which decides upon the fraction of data sets which we are going to augment. Like when our program will be running, you will see that we are deciding upon the which how much fraction of data set we are going to augment upon. So this is the function which is dealing with it. Now this is an encode function which basically calls upon the Swedish word and the encode every line of the particular data set one by one, and after augmenting it, you can see here it appends basically in a list, which is nothing but an augmented list of the data set which we'll be using further for our classification task. So, having understood it, let's see how the actual program is running. Here we have defined a list of various percentages which will be using it further, and calling our training data frame, and depending upon those percentage we are iterating upon it and deciding upon how much percentage we are going to take for the classification task. So at first we have not done any augmentation. We have straight away gone and performed the classification using SGDC classifier, and we have got our result which we have shown in the slides, and I will show it here as well. And after doing that, this is where the real augmentation is happening. You can see we are iterating upon every line
Roles.
of the data set, and every line of the data set is passed to one of the functions of the class augmentation, where the EDA method is getting performed, and we are getting the augmented set. And once we have got the augmented set, again the same thing, we are doing the classification task, and we are getting the results. So this is how our results looks like. You can see the 10 percentage mark, what is the precision, recall, reference score, what is the accuracy. Accuracy we have already shown. Since it was a binary classification task, we decided to rely upon the accuracy as our primary result. And since the data set is also quite balanced, and you can see it is there for the 10%, it is there for the 20%, and you can scroll it and see it. Basically it is for from 10 to 100 we have done it for each of it. Now this is how the implementation of EDA. Now the how EDA is actually getting performed, we'll move on to a next file where the EDA has been implemented. So this is the EDF file. We had where we have a class called ankle data augmentation. Basically, what it does, it find out the various it implements the EDA where various functions has been implemented. We can see that this is the function which is getting. Uh, I'm going down. So this is the function which is get basically performing the synonym replacement part. This is the function which is getting the vectorized form of the synonym from the word to vec model. This is the function which is performing the deletion. Then this is the function which is performing random insertion and so on. So depending upon how much percentage of different part of the EDA you want to implement, um, these functions are getting called. So this is the key function which our implementation part is calling. You can see it is giving the percentage of the synonym replacement, random insertion. RS is like random deletion. RD is random deletion. So depending on the percentage, the number of words which need to be replaced, inserted, and deleted are calculated, and those functions which I have shown above are getting called, and accordingly the augmentation part is taking place, and things are getting augmented. So this is the one part of the EDA. Moving ahead, I'll talk about the other methods. That is the POSSR and random POSSR and noun replacement. It's very the setup stuff is very similar. We have again read our data set. We have sorted it out in terms of whether it is corrected sentence or the original sentence, as I am highlighting on my screen. It's the same thing which I have explained earlier. Nothing much. The same methods have been followed. And okay, sorry, I was showing the wrong file. The same method has been followed. And moving ahead, again the same thing. We have divided, taken a data set in terms of the various percentage, and we have performed the classification task, as you can see over here. Now the main change lies where we are how we are going to perform the augmentation part of it. You can see here the function is different. Here I am using this something called type synonym replacement function, and I was specifically passing the noun. So in other method, if I'll not pass this noun, it will basically perform a POSSR. The code itself will decide which part of the speech it will take, and to perform the replacement. If I'm very specific about it that you have to take the noun only, it will take the noun only. So this is the main line where the change is there, and where this function is defined. I'll show you briefly. So this is the where it has been defined. This is the separate Python file where the synonym replacement part has been defined. Coming to the synonym replacement part, so this is the main part, or I can see the main heart of the code, where you see if I am specifically passing the token type. If it is not there, it is taken as none. If it's taken as none, it will randomly choose one of those uh, part of speech and perform the synonym replacement. But even if I'm very specific about it and I'm passing it either one of them, we have not tried it up specifically on the other part of speeches. We have only tried it upon noun. So if you are very specific that you only need a noun, it will take noun, and it will subsequently call on the other functions which are like defined at the various levels, so that those synonyms are synonyms based on the part of speech are correctly identified and replaced. So this is the file. If somebody wants to look how it has been implemented, this is how it goes about. It calls this type synonym SR function. From here, it gets handed over to get synonym vector, where it gets the particular vector of that vector which is very close to that particular part of speech and the word which this method has identified, and subsequently it is getting replaced and appended, and it is getting returned. So this was a very brief description, though it was not really possible for us to uh, explain each and everything. The course has already been very huge, but we have tried to explain the how this are basically arranged in various files and how it can be implemented. As far as the implementation part is concerned, it is very simple. Every Jupyter file is separate in itself. If all the dependencies are installed, and You can see the path which I have given. It is of my computer as of now. If somebody wants to run it in their own computer, it just a path you need to change. Though before submitting the code, we will make it we'll make it you need not to change the path itself until and unless it is there in the same folder. We can basically run the Jupyter all the Jupyter file independently, and if the depending py file is there, all methods will run. Only constraint will be the it takes a lot of time. It takes approximately 1 to 1.5 hours for a particular method to run and give it a result for one, say for the specific 10 the specific percentage. So only that will be a drawback. So use of TPUs are recommended to run this project. So that was our result which we have got, we have already shown. So I think that was it. So we will move towards the next part, that is the future work. I
So
think
yeah.
Tarun will be able to explain the future work better. He's already got a few plans in his mind.
Yeah, yeah, thank you. For the future work, what we wanna do in the future work is that here what we have done, we have used a rule based method. Although, for example, EDA, for EDA we have used many, we have defined many methods. For example, random synonym replacement, random insertion. All these methods are rule based method. Okay, so what we are thinking in the future, or what one can do in the future, is use transformers to to augment the data. Okay, so when we use transformer to augment the data, and then this rule based method, for example here we have used EDA, so how we can get a better augmented data. So what one can do in the future, that take the data set, do the EDA and or perform any rule based method, and take some augmented data from that rule based method, and then apply the augmentation using using the transformer, and from that transformer he can take the augmented data. And now we have augmented data from both the side using a rule based method and transformer. Now what we are going to do, we are going to see we are going to use a you can say matrix. For example, there is a matrix called cosine similarity or Jaccard similarity. Using that similarity we can see that which two you can say we can see that which are the augmented vectors which are very similar, and we take the similar vector, or we can say we can take a top 10 similar augmented vectors, and then we can perform other downstreaming tasks on those selected vectors, because it is very obvious that those similar vectors which have the highest Jaccard similarity or cosine similarity will give a best result, because it is best from both methods. So this is how one can do in the future work there, where he can implement both the task, rule based method, and the use of transformer or large language model to augment the data, and take the best result out from there. So let's dive toward the conclusion. So in conclusion, what we have done, we have used three different methods for the data augmentation. All are the rule based method, and for this data augmentation especially, we have done this data augmentation task for a low resource language situation, where we have used Swedish language, and we have highlighted the effectiveness of the proposed methods within the diverse low languages resource. Although the work which we have done have a great scope in future. There are many limitation of these methods. For example, one big limitation is only this is a rule based method. Sometimes sometimes it will not applicable on other languages. For example, if we go in other low or scarce language, low resource language, for example, take an example of Indian Sanskrit, where we don't have you can say we have a dictionary, but we don't have any word to vec kind of model for those languages. So there, these rule based method will not work that well. So these are the limitation, and hence this is the conclusion. Thank you very much.
Thank you.